Hi, welcome to tutorial part 2 of the LCD programming. You see, yesterday I was just demonstrating some LCDs basic programming principles. So if I let you have a quick look, I've wired the lead up to the larger display just for these videos. You can actually see it. I suppose looking at the clock there just gives you an idea what you're going to do with an LCD. We could start by making a clock, put in a fancy acrylic case. This is actually black perspex. Yes, you saw the text on the first screen, first row, and it's just scrolling random text on the second. So Pic tutorial, LCD demo part 2. Have a look at yesterday's video, part 5. In total it was anyway. Part 5 gives you the RAM address and explains more about scrolling text. Right, so going from that, I was using a Pic 16F877 yesterday. Here today, you probably can't see it with this massive wire, I'm actually using a 16F627 just to demonstrate you can run an LCD on these smaller chips. Doesn't have to be a 40 pin 877. Right, so if I go to the screen, before I show you all of this programming, the basic connections, the Pic 16F627, you might want to pause your video, jot these down something. Hopefully in focus there. So 4 connections for data, register select, E for enable, VSS, ground, read write, just ground it, VE may need a contrast pot, power, and obviously power and ground for your chip. The crystal is not actually shown here, but have a look on the data sheet. Get a crystal and 2 caps, or just stick a ceramic resonator. Let me find the data sheet for you. Ceramic resonators, just use 2 pins straight across OSC1, OSC2. Have a look at my other videos, give you an idea. Right, what you need to get done, just save unplugging the chip, putting it in the programmer, then putting it back in and making corrections to your program or whatever. It's a lot easier if you just use the in-circuit serial programming. So on the 16F627, which the 16F84 doesn't have, you want the programming data, programming clock, master clear, then ground and 5 volts. They're the 5 connections that you need for your PicKit 2 programmer or PicKit 3 programmer. If you wire your chip up to the LCD and wire those 5 connections, you don't have to keep on turning the chip out. Just alter the program and keep on programming it. Right, reduce that. So that's the wiring once again. Note that RA4 is 10k pull-up resistors, open drain or open collector, so you need to pull it up to 5 volts. Little regulator, 9-volt battery if you want one. Right, you've got all that. Hopefully, well, you can pause the video and just copy it. That's the minimum requirements. Microcode Studio and the PIC, it assumes that without any data written, you're wiring up like that, then you don't have to define any connections as you do with the 877. Right, get rid of that. There's a quick, this is the 877 yesterday. I was using a 5 Molex pin for ICSP, in-circuit serial programming. Pin 1, master clear, pin 2 is supply, pin 3 is ground, 4, programming data. Have I got that right? Yeah, programming data, programming clock. So data and clock, so that suggests it's synchronous. The data is synchronized with a clock, as opposed to asynchronous, which is like serial LCDs where the data and clock sent in serial form. These programmers synchronize the data with the clock. So this is synchronized, not asynchronous. Right, get rid of that. Don't need to save any changes. Right, back to, what's this other one I've got open? 67, right. You see yesterday we had the 877 running the display. We did define the data port, enable port, register select port, that sort of thing. We had to use adgon1 equals 7, sets of ports to digital. Well, on the 627, we just choose A equals 0, CM com equals 7. Gives you digital outputs on A, I believe. Right, on this program, we're using I as a variable byte, B2 as a variable byte. You can actually put any letters or numbers here, but they're just variables we're going to work with in the program. We've got port B5, which is actually pin 11 on the 627. We're putting a switch on there, so we just call it SW1 for switch 1. It's variable port B.5, so it's going to vary. It's either going to be on or off. As you saw at the beginning of the video, clears the screen and displays hello YouTube, pauses for 8 seconds, then goes into a loop. But then forget the switch for a minute. Yeah, loop, clear screen, pic tutorial, as same as yesterday. LCD demo part 2. See this $C0? That's displaying on line 2. Pause for 3 seconds. Clear the screen again. And this is our counting. So for B2 128 to 207, have a look at the demo yesterday. These are the RAM addresses, starting at 128 on the first line, finishing at 207 on the second line, and it's just pushing the text forward. Scrolling down, here it's telling us to go to loop 1. This is loop 2. Right, so now, just rather than just have scrolling text, doesn't really do a lot. I just move my chair. If I look at the board, so what I did was put a switch. You remember port B5, it's actually pin 11 on the processor. I don't know if we can get all this in actually. So if you watch the screen, and I'll demonstrate the reason why you want in-circuit serial programming. Right, have a look at the LCD. If I ground this, right, so I've grounded a pin. It's gone show subroutine, second line of text. Right, so disconnect it. It's stuck there. So quick, yeah, it's just a gentle guide into more detailed programming. What we did, so let me find it for you. Right, in this loop 1, at the beginning of loop 1, if SW1 equals 0, so if we've had, do you remember we called port B5, we called it a switch 1. If switch 1 equals 0, then go to loop 2. So I grounded that pin and it jumped to loop 2 to display the second load of text, which is loop 2 down here. Clear the display, and you are focused. Clear display, LCD out show subroutine, LCD out $FE $C0 second line of text, and that's it. It's gone to here and it's stuck there. There's nothing to tell it to go back. So this is why you want in-circuit serial program. You made an error, go back, or you want to change the program quickly and try something else, see if it works. Right, rather than use this go to, delete that and put go zub. Go zub is go to a subroutine. Right, so I've already got the Pic Microcontrollers programmer installed in the background. I can just hit F9 and it's programming away. Right, so then it starts the video again. That was coming on for 8 seconds. Pic tutorial. Right,